Alright, so in this video I'm going to be going through the GCSE Maths paper 1, which is a non-calculator paper. It's also a foundation paper, and it's from the Specimen Set 1 set of questions. So let's begin going through it. So the first question says change 530 centimeters into meters. Well, in order to do that, we'll use the fact that 1 meter is 100 centimeters. And then using this fact, we could then write out what 530 centimeters is, because again, going from here to here, you're multiplying by 5.3. So if we do the same, we get 5.3 meters. Okay, next one, how many minutes are there in 3 1/4 hours? Well, what we can do here is we can use the fact that 1 hour has 60 minutes in it. So if 1 hour has 60 minutes, then that means that 3 1/4 hours must have, so we times by 3 1/4 times by 3 1/4. And that should give us, well, 60 times 3 is 180, and then 1/4 of 60 is 15, so it's 180 plus 15, which is 195. Oops. Should be 195. Okay, next one, we need to write this number corrected 2 decimal places, which means that the second decimal point is this one here. So it's the 3. So we look to the right. Since 5 is there, that means we round it up. So 4.4354 can be written approximately as 4.44, and that's correct to 3 decimal places. Okay, writing 0.9 as a percentage. Again, remember to turn things into percentages, you just multiply by 100. So if we start off with a decimal, to turn it into a percent, we multiply it by 100. And when we multiply by 100, we move the decimal point twice, so we get 90%. Okay. We have to work out now minus 3 to the power of 3. So minus 3 to the power of 3. What that basically means is you get minus 3, you multiply it by another minus 3, and you multiply that by another minus 3. Making sure you're careful when you do it. And so if we do that, minus 3 times minus 3 is 9, and then times another minus 3, which gives us minus 27. Okay, so now here are 4 cards. There are numbers on each of the cards. Write down the largest 4-digit even number that can be made, assuming that you only use the cards once. So what you can do here is you can start off by thinking you have 4 digits, like so. Now, for the largest number, that means that we have to order the numbers from biggest to smallest. And then, since we need it to be even, that means the last digit needs to either be a 4 or a 2, because those are the only 2 even numbers that we have. So if we say that the last digit is either 4 or 2, and we start off by filling the first digit, so the biggest number we have is 5. Then the second biggest is 4, but remember, the last digit could only be 2 or 4. So if the second one has to be 4, that fixes the last one as 2. So we have a 4 here. This one has to be 2 to make it even, and then there has to be a 1 here. So our number is 5412. Okay, now it says write down all the two-digit numbers that can be made using these cards. Again, I assume that you can't repeat the cards, sort of like it said above. So we have to use this one, this one, this one, and this one only once. So if we do that, we can sort of start off by looking at the number 1 and sort of finding all the other digits that can make a two-digit number. So we could use the 2, we could also use the 4, or we could use the 5. Now we do the same by fixing the first digit as 2. So the next one can be 1, next one can be 4, next one can be 5. Now we fix 4 as the first one, so that it could be 1, it could be 2, or it can be 5. And now we fix the number 5 as the first digit, so it could be 1, it could be 2, or it can be 4. So as we see, we have 12 numbers altogether. So 12 numbers which can be made, Okay, perfect. Next one, so we have a table, and as we can see, the table sort of has some information. All of the information in the table is discrete. So what that means is that they're sort of fixed numbers, fixed whole numbers, and they don't take any range of values. And so what I am thinking is draw a bar chart. So I'm just going to write that here, draw a bar chart. And that's because we have this sort of discrete data. So if I draw sort of my axes up here and along here, have there, sort of up here. So the y-axis can sort of be the number of students we have. So I can sort of write that sort of over here. So number of students. And then the x-axis can be sort of the different sports that we have, sports. And so now I sort of need to figure out what the labels are going to be for our axis, sort of the divisions. So we have 1, 2, 3, 4, 5, 6, 7, 8 spaces, and our range of values is from 1 to 15. So I'm going to decide to go up in 2s to make sure we can get all our values. So 2, 4, 6, 8, 10, 12, 14, and 16, like that. Again, of course, this point is 0. Okay, so that's 0. Now on the x-axis, we sort of need to fit our bars, so sort of the widths for each of the sports. So we have 4 things. So we have hockey, tennis, football, and golf. And each of those has 2 bars or 2 sort of main data points within there. So what I can do is sort of firstly figure out how much space we have. And so we sort of have on this one, we've got 1, 2, 3, 4, 5, 6, and then 7 lines, which means that in total we have 1, 2, 3, 4, 5, 6, 7. So yeah, that should work. But again, because just for visual purposes, I don't want the bars touching the y-axis. So what I'll do is I'll offset my starting point to around here. And then also because I want a gap between the bars, I'll also leave sort of a little gap. So what we'll do is we'll start here and then go to here. So this will be our hockey. So this will be our first one. It's hockey. Then what I'll do is I'll sort of leave a gap and start here and then start here. So this will be my second one, so it'll be tennis. And then what I'll do is I'll leave a little gap, so start here, then go to here. So this would be football. And then what I'll do is leave another gap and then go over here. So this would be golf, like that. Okay, so now that I have that, now it's just a case of drawing everything on. So what I will do is use a key to denote my different bars. So what I will do is I'll color blue for boys. So this would mean boys. And then I will use purple for girls. Purple, and this will be girls. Okay. So now let's fill it in. So the first one, hockey, has 3 boys, 6 girls. So 3 boys, 6 girls. So that will be hockey. So let's use this one. That'll be 3. Let's do it there. 3, and then this one would be 6. And then sort of fill it in like that. Oops. Let's connect it up. Okay, now for tennis, we have 8 and 4. So let's go to tennis. That's 8 is here, and then 4 is here. I think, there we go. Oh, sorry, 14. Sorry, not 4, 14. So that's up here. Okay, now connecting everything up, making sure that when you guys do it, it's important to use rulers. That way you sort of don't get these weird wonky lines. So the next one is football, 15 and 7. So football is 15, which is all the way up here, I think. Again, we're leaving a gap, and then 7 is sort of down here. Again, connecting all those up. That, like this. Like this. And then the final one is golf, which is 9 boys, 9 boys and 1 girl. So 9 is over here, and then 1 is down here. Okay, so then connecting everything up. Okay, great. And now what we can do is sort of shade things in a little bit. So we'll use blue sort of lines to cover up the boys. So boys would be this one, and girls would be the purple one, far up to here. And this one is the boys again, shading it like that. Girls would be here. Again, boys up here. Girls here. And we have boys here. And then we have girls here. Now, just some advice. If you do not have colors, then you do not need to use colors. Instead, you could just shade it in with your pencil. Let's just say you shade boys in and then leave the girls blank. And that will also be fine. Okay, next question. It says, Bernard says, when you halve a whole number that ends in 8, you always end up with a number that ends in 4. Write down an example to show where this is incorrect. Well, firstly, let's list out some numbers which end in 8. So we have 8, we can have 18, 28, 38, 48, and so on, just by sort of varying the first number and keeping the last digit the same. So if we do that, as we can see, let's just pick the second one, so 18. So an example is 18. So 18, and we can say if we halve 18, we get 9, right? And 9 is not the same as 4, or anything that ends in 4. The next one says, because 7 and 17 are both prime numbers, all the whole numbers that end in 7 are primes. Again, list out the numbers which end in 7. We have 7, 17, 27, 37, 47, ... I'm going to say the first one that comes to mind is 27. Oh, geez. So 27 is the one that I'm going to use. So is Alice right? Nope. So Alice is wrong, since 27 is not a prime. And the way we know 27 isn't a prime is that we can write 27 as 3 times 9, so it's divisible by 9 and 3 as well. Okay. Cool, next one, so we have some multiplication. So what I'm going to do is just write it out like this. So 3 times 7 is 21, so put the 1, 2. 3 times 12 is, 3 times 4 is 12. Add the 2, it's 14. 3 times 2 is 6. Add the 1, that's 7. Okay, hopefully I've done that correctly. Then we add a 0. 6 times 7 is 42. So 2 over the 4. 6 times 4 is 24 plus 4 is 28. So we add the 8 over the 2. 6 times 2 is 12 plus the 2 is 14. And now sort of adding these up, you get 1, 4 plus 2 is 6, 7 plus 8 is 15, carry the 1, 4 plus 1 is 5, and then 1. So the answer to this, 247 times 63, is 15,561. Okay, so the next one says an American Airlines has a maximum size for the bags that you can take on the plane. The dimensions for this maximum size is given in this diagram. It then says Chris has a bag, and the bag that he has these dimensions. Can he take his bag on the plane? Well, notice the units of this and these are different, so we need to make the units the same somehow. So what I will do is convert all of these dimensions of the bags to centimeters and then compare. So we'll do it in the same order so we can calculate the height. So what we'll do is firstly say, so the max dimensions in centimeters, we could write it like this, something like this. So we have the height, and that would be 22 inches times by the fact, which is 2.54. And if we do that, 22 times 2.54, we get 55.88 roughly. If we do now the width, which is 14 times by 2.54, we do the same thing and see what we get. So 14 times this amount would give us 35.56, and the depth D would give us 9 times 2.54, and if we do that, we should get around 22.86. Now all of these are in centimeters now. So now what we can do is we can say comparing Chris's bag dimensions to the max dimensions, we see that, now if we have a look, we see that the height of Chris's bag is fine. The depth of Chris's bag is also fine, right? But the width of Chris's bag is too big, so he wouldn't be able to take it. So we see that all the dimensions are fine except the width. And then what we can say is, since the 40 centimeters of his bag is bigger than the 35.86 centimeters, which is the maximum, he cannot take his bag with him. Okay, great. Next one says complete the two-way table. So it's sort of a bit like Sudoku. You just sort of have to fill in the gaps. So here in this first one, the total is 12. So 5 plus 4 is 9. 9 plus what gives you 12? Well, it's 3. Here in this one, 4 plus something gives you 9. So that has to be a 5. Then here you also see 12 plus something gives you 30. Well, that has to be 18. Now we can see from here, 7 plus 5 gives you 12, but that 12 plus something has to give you the whole 18, which means that that must be 6. And then now here, 5 plus 6, well, that has to be 11. And then here, 3 plus 7 has to be 10. And now just double checking, 11 plus 10 is 21, plus 9 is 30, and that matches what it should be. So we're done. Okay, now there are 28 red pens and 84 black pens in a bag. Write down the ratio of red pens to black pens. So the order of this is important. So what we say is number of red pens to the number of black pens. So if we're writing this, red pens is 28 and our ratio is to 84. And now we just simplify, so we could halve this, so that will give 14. This would give 42. Write that out. And then we could sort of, they're both even, so we halve them again, so it's 7 and 21. And now we see that 7 goes into both, so that goes 1 time into 7 and then 3 times into 21. So the answer in its simplest form is 1 to 3. And you need to make sure that if it asks for simplest form, you make sure that you do that. Otherwise, you will lose some marks. Okay, so here it's talking about sequences of tiles, and it asks us to draw pattern number 4. Well, as we can see, the grey tiles are going up in ones, and so are the white tiles. So in pattern number 4, it would have to be 1 up from pattern number 3. So we'd have our grey tiles, which will look something like this, and you'd have 6 of them. So 1, 2, 3, 4, 5, 6. I know mine aren't even, but ideally yours should be even, and then we'll color them in grey just to make it a bit obvious. So we have those. So again, they should be evenly spaced if you can, especially if you have a ruler, but I just I've done it like this. Then the white ones again would have to be sort of from here to here. And again, there should be 4 of those because those increase by 1, 2. So 1, 2, 3, 4, like that. Okay, so now it says find the total number of tiles of pattern number 20. So firstly, we need to figure out what's happening to the total number of tiles through each pattern number. So for this first pattern number, the total is 4 tiles. Then this second one, the total is 6. Then this one's 8. Next one's 10, and it's sort of going up in 2s like that. So if we write that down, so the first pattern number, you start off with, was it 4 tiles? So this will be pattern number. This will be number of tiles. So the first, and for the second one, you have 6, and then 8, and then so on. So what we can see is sort of we can find the nth term, so it's sort of going up in 2s. And if it's going up in 2s, then we know that the nth term for this should be 2n, which is again comes from this difference. But then because it's offset from 2n, we need to add 2 to that. So the 20th term would be just be plugging in 20 into there. It should be 42. Okay, the next one says write an expression in terms of n for the number of grey tiles in pattern number n. So let's see the link between pattern number and grey tiles. So here we have 3 grey tiles in pattern number 1. In pattern number 2 we have 4 and then 5. So again it keeps going up in ones for every pattern number. So let's write that out. So pattern number, I'll just spell it out fully. It's pattern number. So you've got your first, your second, your third, and then let's just go to your nth pattern number. And then let's just say what happens to your grey tiles. So grey tile starts off with 3, then 4, then 5. And so as we see, from the pattern number to get to the grey tiles, you'll just have to add 2, right? So if the pattern number is n, like it says sort of in the question, then to get to the number of grey tiles, we sort of need to add 2 to that as well. So then n plus 2 just gives you n plus 2. Okay, so in this question, what we have is we're told a unit of gas costs 4.2 pence. On average, Ria uses 50.1 units in a week. She pays for gas she uses in 13 weeks. Work on estimate for the amount that Ria pays. So again, estimate means that we need to do some rounding stuff. So this means round. So if we're rounding, let's just say 1 unit of gas is approximately 4p. Then on average, so in 1 week, Ria uses, let's just say approximately 50 units by rounding. And then let's just say she pays for the gas she uses in 13 weeks. So therefore, an estimate for the amount she pays, so amount Ria pays. So the amount that Ria pays will be the amount that she gets in 1 week. So she gets 40 units in 1 week. So she gets 50 units in 1 week, 50 units in 1 week. And each unit costs 4p, so you multiply by 4. And then she does that for 13 weeks. So we do this. And again, the unit is all in pence. So 50 times 4 is 200. And multiplying by 13. Again, if you can't do these, then just do a little thing up here. So you get 006 and then 002. So its total is 2600. So it should be 2600. That's in pennies, which is equal to £26. So that's roughly how much she pays. Okay, is our answer an underestimate or overestimate? Well, the answer should be an underestimate, right? So an underestimate. And the reason why it's an underestimate is because we rounded, all our approximations rounded the numbers down. So we turned 4.2 into 4, and then we turned 50.1 into 50. So all we've done is made our numbers smaller, so our actual value would be higher. So the current thing that we have is an underestimate. So underestimate, since we rounded our values down. And what I mean by that, i.e., we turn 50.1 as approximately 50 and 4.2p as approximately 4p. Okay, so now we have a scale diagram of a floor. We're told the sort of scaling, and this person wants to cover the floor with boards. Each of the boards has this sort of dimensions, and we need to figure out if she has enough boards. So she has 150. So let's look at what one board is. So if we look over here, so we have one board that we're given. So one board, it says it's 1.2 meters long and 1 meter wide. So it looks like this. And we want to see sort of how many of these can we fit inside this and sort of what it would look like. Well, firstly, if we measure out the sort of sides, we would get this side is 3.5 centimeters, which from this scaling is roughly, well, it is 7 meters because you're just doubling it. And the same thing for this side. This side would roughly be around 10.5 centimeters, which is 21 meters. So now, to see if we have enough boards, we could sort of find the total areas and see if they sort of fit. So area of one board would be 1.2 times 1.2 meters squared. So then what we could say is the total area of all boards would be equal to, well, we have 150 of them. So it would be 150 times by 1.2, which would be, well, 1 times 150 is 150, and then 0.2, which is a fifth of it, was 30. So in total, you'd have 180 meters squared for all boards. And now, because we've measured sort of the area of our floor, we can sort of say the area of floor would be just, well, 7 times 21. If we do that, it's 147 meters squared. So now what we can say is we can say, since the area of all boards is bigger than the area of the floor, i.e. what we're saying is we're saying that 180 meters squared is bigger than 147 meters squared. What that says is that we then have enough boards. So since the area of all boards is bigger than the area of the floor, we have enough boards. Or when I say we, I mean Miss Bridges. Okay, so next question. So to answer this question, what I can do is it says work out the area of the shapes. Well, I can split up the areas. So we can say that this is the first shape, this is the second shape. Now let's just fill it in here. What we can do is we can say this side is 2, and therefore this side has to be, let's do it in a different color. This side has to be 6. So we can find the area of 1. Well, that would just be 2 times 10, which is 20 centimeters squared. And the area of 2 would just be 6 times 2, 12 centimeters squared. So therefore, total area, we just add them up. So we add the 20 and the 12, which gives us 32 centimeters squared. Okay. The next question says, on the grid, rotate the triangle 90 degrees clockwise about the point 0, 0. So marking on the point 0, 0. Now, what you do is you just get tracing paper and sort of outline the points like this. and then sort of rotate your paper clockwise. Again, clockwise is this direction. So clockwise, I'll just do this way. Clockwise is this direction. And so if you do this and you do rotate your shape clockwise by this amount using your tracing paper, you should end up with a shape which sort of looks like this. So it should be here at this point, it should be this point, and then it should be this point, and then we'll connect it up. So this is what we have, and this is your rotated shape. Okay, there is another way of doing it without tracing paper using the rotation matrix and then multiplying it by the vectors of the vertices of the shape. But again, this is beyond the scope of GCSE and in particular beyond sort of the foundation, so I won't use that method. Okay, here there are 500 passengers on a train, 7/20 are men, 40% are women, the rest are children, figure out children. Well, we can do this step by step. So if 500 are on the train, we can find the number that are men first. So number of men would be 7/20 of our 500. So again, multiplying fractions, you multiply side to side. So 7 times 5 is 3,500. 20 times 1 is 20. And then sort of we can cancel the zeros. So we get 350 over 1. That's just 350. Then we could do the same for women. So number of women. Well, 40%. So 40% is 40 over 100. Again, timesing that by 500, which is the number of passengers. We do it side to side like this, multiplying. So 20. So 4 times 5 is 20. Then we have 3 zeros. And then 100 times 1 is 100. Cancelling the zeros, we end up with 200 over 1, so it's 200. And so that's women. So therefore, what we can say is number... Oh, actually, hold up. Sorry, this one over here made a slight mistake. So this is over 2. Here's over 2. And this should be 150. Again, that wouldn't have made sense because then the total is more than the number of passengers. So now the number of children, this would make sense, would be equal to, well, all the passengers, you take away the amount that are men and then take away the amount that are women. So if you do that, it's sort of another way of writing that is, so it's 300, take away 175, and then 300 minus 175 is 125. So then number of children is 125. Okay, so now we have a shop. The shop sells different amounts of milk, and this person, Martin, he has no milk, and we need to work out the smallest amount of money that Martin needs. So the shop only sells milk in these proportions. So to figure out the amount that he'll need to spend, firstly, we can figure out the amount of milk that he'll consume on average. So amount of milk Martin needs. Well, the amount of milk Martin needs is that he has 3/4 of a pint each day, and then he needs enough to last 7 days. So that means he has this amount, 3/4 each day, and then for 7 days you just times by 7. So that will give you 21 over 4, which if you calculate that, that would be 4 goes into 21 5 times, remainder 1 over 4. So this is the amount of pints per week. that he needs. So now that he needs that, now he cannot directly buy this amount of pints. And the reason is the shop doesn't have this precise amount. So what we'd need to do is, in order to cover this amount, he'd have to buy 6 pints at least of milk. So would have to buy at least 6 pints per week. So if he needs at least 6 pints, now using the information here, we can calculate which one gives us the cheapest value for 6 pints. So I will label this one 1, this one 2. So via method 1, what we can do is calculate the cost. So 1 pint equals 52p. And what that means is that 6 pints would just be 6 times 52. So 6 times 50 is 300, and then 6 times 2 is 12, so it would be 312 pennies. And via method number 2, we know that 2 pints cost 93p, right? So that means 6 pints of that, you'd have to multiply it by 3. So 3 times 93. So 3 times 90 is 270, and then 3 times 3 is 9. So in total, that would be 279p. So as we can see, the smallest, so the best deal would be to buy from method or from choice number 2. And in pounds, that would be, what was it, £2.79, just converting that into pounds. So now it says Martin actually uses more than 3/4 of a pint of milk each day. How would that affect the money? Well, if he buys more than 3/4, that must mean that the amount of milk he would need would be bigger, because again, this number is increasing. So what that means is that he would have to potentially buy more milk, and it would cost more. So what we can say, and to make that precise, is that if he buys how much over, so if he buys, if he uses more than 3/4 of a pint, he would have to spend more money, and in particular, he would have to buy an extra 1 pint bottle if he uses more than 6/7 of a pint a day. Okay, cool. So the next one, it's a diagram. It gives us a right angle triangle. All angles are in degrees. Work out the size of the smallest angle. Well, notice we can use fact. So use fact. Total angles in a triangle add to 180. So if we use this fact, then what we can do is add up all the angles. So we've got a 90 degrees plus a 7x plus another 5x plus 18. Again, we'll put those in brackets if you want. And all of those added together gives us 180. Rearranging this equation, we can get 7x plus 5x plus 18. Sorry, rearranging, we'll do it in one step instead. So we'll say that the angles added up, so 7x plus 5x, we'll add them together, that gives you 12x. And then the 18 plus the 90 gives you 108. So then moving the numbers to one side, we get taking away 108 from 180 gives you 72. And then dividing by 12, it gives you 6. So work out the size of the smallest angle on the triangle while figuring out all of the angles. So if x is 6 degrees, then 7x, so would be equal to 7 times 6, which is 42. And 5x plus 18 would be 5 times 6 plus 18, which would be 30 plus 18, which is 48. So this one is the smallest. And because the other one is just 90. So the smallest one is 42. Okay, next one, it says a box exerts a force of 140 newtons on a table. The pressure on the table is this. So it's giving you some info here. Calculate the area. So basically this requires using this equation. So if we know that the pressure is equal to the force per unit area, then if we rearrange this, we get the area is equal to the force over the pressure. So then using that, our area is our force, which we're told is 140 newtons, and our pressure is 35 newtons per meter squared. So that's using these lines here. Okay, and so if we do that, then we get, so how many times does 35 go into 140? Well, 35 plus 35 is 70, so that goes in 2 times, and then 70 is double 140, so it actually just goes in 4 times. And again, the units of that, because this is newtons and then this is also newtons per meter squared, the newtons cancel, so you're just left with meters squared for the area. And that makes sense, right? Because area should have a unit squared as the sort of form of measurement. Next one, it says there are only red counters, blue, green, and yellow in a bag. So we've got this. The table shows the probabilities. And it tells you the probability of picking a blue counter is the same as the probability of picking a green counter. So these two numbers are the same. Complete the table. So what we need to do is use 2 facts. So the first fact is this. Okay. And then the second fact, so use this. So use this and total and fact total probability equals 1. So if we use those facts, let's call this, so let probability of getting a blue equal the probability of getting a green, and let this value be equal to x. So then what we can do is write an equation. So we get 0.24 plus 2 lots of this x plus 0.32 is equal to 1. And this is just got by adding up all of these things. And if we total this together, we get 2x plus 0.56 equals 1. Means 2x is equal to 0.44, which means that x equals 0.22, and so each of these is 0.22. Okay, Good. Now it says a pattern is made using identical rectangular tiles. Find the total area of the pattern. Well, if they're identical, then using this, we can sort of figure out what each of the sides are of the rectangle. And so in order to do this, we can basically, because we don't know the sides, we can call them certain letters. So I'm going to say, imagine this side of I'll use a different color. So this side is X, and then this side is Y, and then we could sort of form some relations out of it. So because we know that all of them are the same, that means this relation tells us that we have the Y plus the little x, and that gives us 7. So using the shape, we can find the relations that 7 is equal to the y plus the x. And then from this side, we know that the y plus the x gives us 11. So then we get 11 is equal to the y plus the x. So now writing these in a slightly neater way, we get these. So we get 2y plus x. Actually, that's x plus 2y equals 11. Now this is now simultaneous equations. So these are simultaneous equations. So if we solve these, we can subtract the 2. So subtracting gives, if we subtract them, we get, let's do this bottom one, take away this top one. So we get x minus x gives 0, 2y minus y gives you y, and 11 minus 7 gives you 4. And substituting that back into here, what we can get is that x is equal to 7 minus y, which equals to 7 minus 4, which is 3. So now we know what the sides are. Then we can say the area of one rectangle. So area of one rectangle would be 4 times 3, which is 12. Again, units will be centimeters squared. So total area would be equal to, now see here, we have 1, 2, 3, and 4 of these rectangles. So we just multiply by 4. So 4 times 12. And if we do that, we get 48 centimeters squared. Okay, cool. So next one. So this is a diagram, shows a sand pit. Sand pit is a cuboid. Sally wants to fill the sand pit with sand. A bag of sand costs £2.50. There are 8 litres of sand in each bag. Sally says the sand will cost less than £70. Show that Sally is wrong. So when they ask you to do this, we can calculate it ourselves. Calculate cost ourselves, and then compare. So if she wants to fill this whole cuboid up, we need to firstly figure out what the volume of the cuboid is. So the volume of this cuboid, or what they call a sand pit, would be equal to 40 times 100 times 60. So if we do that, 6 times 4 is 24. And then we'll have 4 zeros. So 1, 2, 3, 4. And that's again in units of centimeters cubed. And then we also know the fact that 1 litre is equal to 1,000 centimeters cubed. And this is basically a fact. So using this fact, we could then convert our volume into liters. So this implies volume of sandpit would be equal to, well, you just see how many 1,000, so divide it by 1,000, and that should give you 240 liters. And so you need 240 liters. And the reason we converted it into liters is here it says that there are 8 liters in each sandbag. So if there's 8 liters in each sandbag, we can figure out the number of sandbags. So number of sandbags needed to fill pit as being equal to the volume of the pit, which is 240, and dividing by sort of the quote-unquote volume of each sandbag, which is 8. And that goes in 30 times. So we need 30 bags. Okay. So now we know that the number of bags is 30. We can find the total cost. So total cost of all bags. Well, we have 30 of them, and each bag costs £2.50. So 2 times that is 60, and then half of that is 15. So 60 plus 15 is 75. So as we can see, this is not the same as thingy. So as we can see, £75 is bigger than £70. So we can say off by 5. So Sally is wrong. Okay. Good. Okay, so the next one, we have 4 friends, each throw a biased coin. So again, this is not a fair coin. It's not like a 50-50 chance or whatever. The table shows the number of heads and tails each person got. Okay. The coin is to be thrown more than 1 time, so multiple times. So Ben got 34 heads and 8 tails. Okay. And then these people got what they got. It says which of the 4 friends' results will give the best estimate for the probability that the coin will land on heads. So the thing about this is sort of it's testing your knowledge of probability, and generally probability is better when you have more number of trials. So when you have a greater number of trials, the probability is a better estimate. So what we can say is that in our case, the answer would have to be Sharif because his number of trials is the most. So what I can do here is I can just calculate a little total just to prove that. So total, so 8 plus this is 42. 12 plus that is 78. 40 plus that, that's 120. And this plus that, that's 160. So we've got something like this. And then, of course, we can total here too. Just in case. So adding up all of these, so 34 plus 66, that would give you 100, 180, and then 300. And then the bottom one, 8 plus 12. So that's 80 plus 20, which is 100. So we have it there. So the answer, as we can see, the highest total. So the answer is Sharif. And the reason is since to get a better probabilistic estimate, you need lots of trials. Therefore, the greatest number of trials trials equals best estimate. So this is one way of sort of determining it. Okay, so now Paul says, with this coin, you're twice as likely to get heads than tails. So in order to show this, we can sort of see, well, calculating this for all the people. So what we can do is firstly do it for Ben. So twice as likely to get heads than tails. Well, if we get their tails number and double it, so the heads equals should be 8 times 2, which is 16. Helen's should be, so let's do that. So 8 times 2, which is 16. This is the number of heads. Then Helen's 12 times 2, which is 24. Paul is 40 times 2, which is 80. And Sharif is 40 times 2, which is 80. So as we see, what Paul is saying works in his case, but does not match up in any of the other cases. So calculating this for the people, we see that only that that this rule only works for Paul, but nobody else. And in order to do this, you need to check the table. So note, check table to see. Okay, final part, the coin is to be thrown twice. Use all of the results in the table to work out an estimate for the probability that the coin will land on heads both times. Well, if it's to land on heads both times, if it's thrown twice, then that means that, and also rolling each time, the events are sort of independent of each other. The probability of rolling once does not affect the probability of rolling again. So here what we can say is the probability of rolling 2 heads would be the probability that you roll heads once multiplied by the probability that you roll heads the other time. And so in order to calculate this, what we do is that we say the probability that you land on heads would be total number of heads over total rolls. So here, as we can see, the total rolls is 300 plus 100, which is 400. And the total number of heads was 300. And so simplifying this, we sort of get 3 over 4 as a probability of heads. Therefore, the probability of getting 2 heads, or another way of saying that is it's the same as saying the probability of heads and heads. So heads and heads would be equal to probability of heads, which was 3 over 4, times by, again, the probability of heads, which will give you 9 over 16. Okay. All right, so in this question, write down the exact value of cos 30. So again, you should remember these, ideally. So just know. Or sketch a graph, right? If you don't know, you can sketch a graph. So cos 30 would be a half. Oh, sorry, cos 30 would be root 3 over 2. It just sort of comes from your standard definitions, but you can figure it out in other ways. Okay, so the next one says, given that sine 30 is a half, work out the value of x. Well, labeling all the sides, so this side's your opposite, this side's your adjacent, this side's your hypotenuse. You see that we need to find this, and we have this. So this would be using our sine function to link it. So x is the opposite. So we can say the sine of our angle, which is 30, equals your opposite, which is x, over your hypotenuse, which is 12. And then from this, you see x is equal to 12 times sine 30. And we're told that sine 30 is a half, so that's 6. So again, when you're told this, use it. So this is important if you don't know. Okay. Now we need to expand and simplify. So expanding this thing out, we can sort of multiply this times this, which gives you x squared. This times this, which gives you minus x. This times this gives you 3x. This times this gives you minus 3. Combining the x's, you get 2 lots of x. And so this is it. Okay. Now we're asked to factorize. So what we can do is use trig, which is known as the difference of two squares. So it's a little trick, which basically says if you have one thing squared and you're taking away another thing squared, that equals that thing plus the other thing and that thing minus the other thing, like this. So here, I'll do it in a couple of steps. So we can write this as x squared minus 4 squared. And here the a is like the x and the b is like the 4. So writing it, you get x plus 4, x minus 4, like that. So it's x plus 4, x minus 4. And our final question says solve the simultaneous equations. So we can sort of make either the x's or the y's the same. So I'll call this one 1, and this one 2, and we'll write them out. So we'll use the same colors. Okay, so we could multiply. So we can make the y's the same because they're the smallest out of the two. So making the y's the same, we could sort of multiply the first equation by 3. And that would make the y's both have 3's in front of it. So if we do that, this equation becomes 12x plus 3y equals 75. And now what we can do is, now that we have this new equation, we can now add these two equations. So now add the new equation 1, which is this, and the equation 2. And if we do that, this 3y and this minus 3y will cancel. And then adding the other two, we get 12x plus x is 13x. And then on the right hand side we get 75 plus 16. So doing that, we get 86 is sort of 11, and then 12, 13, 14, 15, 16 gives you, I think, 91. So double checking that. Yeah, that makes sense. And then what we can do to figure out what x is just move it to the other side. So like this. And if we do that, we can sort of just try it roughly. So it roughly would be around 6-7 times. So if If you try that, you should get 7. And now we know what x is, we can plug it into the first equation and figure out what y is. Right? Now substitute this back into, let's choose equation 1. It doesn't really matter as long as you're consistent which equation you put it back into. So we'll put it back into 1. So we get 4 times 7 plus y equals 25. That means you have 28 plus y is equal to 25. And then, of course, y would be equal to minus 3 by moving the 28 over and making it minus. So then we have x equals 7, y equals minus 3 as our answers. Cool, so that's it. I think that's the end of the paper. Yep. So thank you for watching. Hopefully this has been useful to you. I'm going to be coming out with more of these videos on, foundation maths, along with potentially down the line, A-level maths, higher GCSE maths, along with other entrance exams. So if you have a request for any of those, then definitely comment so that I know.